so after learning the graph for all the trigo function, all right, like sine, cos, and tangent, this video we are going to discuss all right, so how to apply the trigonometry identity. Okay, so for the learning outcome for this video is actually in AS level syllabus, they actually only include two basic identity only, which is tangent equals to sine over cos, and also the other one is sine square plus cos square equals to 1. So for today, we are going to focus on this. All right, so you will see that for AS syllabus, the trigo identity is quite simple. They only include these two. All right, so if let's say you learn something like double angle formula, or maybe the compound angle formula, all those things will be covered in A2 syllabus later. All right, so for AS1, it is quite basic. To me, I think it's quite simple. All right. Okay, so let's have a look for the identity here. Okay, so as shown, if let's say you are interested to know how we get the tangent theta equals to sine over cos, this is the proving part. All right, by looking at this figure. All right, so you can try to spend some time to go and have a look. All right, but no matter how, the formula for the identity is tangent theta equals to sine theta over cos. Then the same thing happens for cos square plus sine square equals to 1 as well. All right, so by looking at the same figure, they actually have all the proving, okay, to get the cos square plus sine square equals to 1. Okay, so these two are very important, of course, in our syllabus here. And then just to let you know that you can actually try to adjust the theta according to the needs of the question. So as an example, if let's say you're having tangent 2 theta, then you should know that you're able to write out become sine 2 theta divided by cos 2 theta. Okay, so if let's say maybe the question requests for tangent x minus 90 degree. All right, so when you want to expand it, become sine and cos, then you follow the angle. So which means that you're having sine x minus 90 degree and then cos x minus 90 degree. Okay, so this is what we have. All right, okay, then what else do we have here is, okay, maybe if let's say they are having tangent square. So when they square the tangent, that means you can also rewrite it becomes sine square theta divided by cos square theta. All right, so this is how you can apply the simple identity like this. Okay, you can change the angle itself, or maybe you can square both sides together. All right, for this identity. Okay, all right. Then now, how about for the cos square plus sine square equals to 1? The same thing happens. If let's say you're having, you should know that you can actually adjust. Okay, so cos square 2 theta plus sine square 2 theta, it is equals to 1. So you can see that you actually allowed to change the theta here. And these two values must be the same. 2 theta and 2 theta, 3 theta and 3 theta, and so on. Okay, so another example is maybe you can adjust it also, like theta minus 45 degree, then plus cos square theta minus 45 degree, and it is equals to 1. So you will see that for this kind of identity, right, you can only adjust the angle itself. You cannot adjust the pattern of the original identity, such as it is originally sine square plus cos square equals to 1. So you cannot tell me that can I change it because sine power 3 plus cos power 3 equals to 1 or not? Cannot. All right, so it is fixed on the pattern, which is sine square plus cos square equals to 1. Okay. All right, then usually for all the identity here, you usually need to apply in proving question. All right, sometimes you might need it also in solving the equation. All right, so for this video, we focus on the proving part first. Okay, so for the proving part question, there are a few ways that you can do it. You can start from left-hand side, and then you prove it to the right-hand side. Okay, and then from right-hand side, you can prove it to the left. Or maybe you can start from both. That means you start from left-hand side, and also you start from right-hand side, and then you go to a step in the middle. That both of them are the same one, also can. All right, so usually for us, we will still prefer students to use either of this method, and then this one come to this one you do it only when you have no option. Maybe you cannot get an answer already, you do not know how to prove, then the other option is you can choose this one. Okay, and then similar like what you learned before. I believe that last time your teacher will teach you like when you want to start, which is the side that you need to start from. you will choose the more complicated side to start, right? And then to prove it to the easier side. So generally, you have to know how to select or how to look at the harder part to start. Okay. All right. So let's have a look for example 4. All right. So for example 4, you're having both sides here. Okay. So for me, I will start from the left hand side. Why I need to start from the left hand side is because of I'm having a bracket with 3 terms, 1 terms, 2 terms, and 3 terms, and I need to expand it. So generally, this is harder. All right, and then right hand side, you'll see that they are having 2 brackets here, and then the bracket comparatively is smaller, so you see that there are 2 terms only in each bracket. So to me, the more complicated one will be on the left hand side. Okay, all right, so we will start from the left. Okay, I will roughly show you how to do it here. Okay, so from the left hand side, you are having 1 minus sine theta plus cos theta. Okay, and then because you square it, therefore you have to multiply the bracket twice. Okay, and then you have to expand these 2 brackets. So again, you expand it term by term. So first term multiply with first term multiply with second, first term multiply with third. So if you expand it, you have this one. Okay, and after that, followed by the second term. So you take the sine theta, multiply with 1, multiply with negative sine theta, multiply with this one. So if you expand it, then you have negative sine theta plus sine square theta, and then minus sine theta cos theta. All right, so just want you to take note that when you are having sine theta, multiply with sine theta, right? Okay, so generally you should write as sine theta square. Okay, but usually what we do is we will write as sine square theta. So these two are the same thing. This term and this term are the same. All right, so don't get confused, right? So these two are the same thing. Therefore, you can see that I'm writing a sine square theta here. Right, so after the second term, then you expand it for the third term. Okay, so let's start with the third term now. Okay, so for the third term is cos multiply with this, cos multiply with this, cos multiply with this. Okay, so if you expand it, then you have cos theta, then minus sine theta cos theta, and then plus cos square theta. Okay, so when you expand it, you'll see that it's very long. That's why it is more complicated. All right, then now you need to try to simplify it and factorize. Okay, so when you want to simplify and factorize, generally, maybe you can look at this one first. You're having sine square plus cos square. So according to the identity that we learned just now, sine square plus cos square should be equals to 1. So 1 plus 1 in front here, you will get a 2. Okay, and after that, negative sine theta, you have another negative sine theta here, so you're having negative 2 sine theta. Okay, then followed by the cos. I'm having cos theta and cos theta here, therefore I'm having 2 cos theta. Okay, and then after that, the last one, sine theta, cos theta, you're having 2 terms. So it will be negative 2 sine theta, cos theta. Okay, so from a long expression here, you simplify into shorter one. And after that, you try to compare with the answer. So you see an answer in front there's a 2. So which is correct because you can see that from your expression, you can also factorize out the 2. Okay, so when you factorize out the 2, then what do you have? You have 1 minus sine theta. Okay, then plus cos theta minus sine theta cos theta. Okay, and after that, you need to further factorize it. Okay, so you can see that I'm having 4 terms here. 1, this is 1, first term, second term, third term, and fourth term. All right, so you need to factorize it into 2 brackets. And if you look at it carefully, you will see that there's nothing else. You can actually factorize it out from the whole bracket here. Okay, so here we want to learn a technique which is factorize only half of the expression. Okay, so to factorize only half part of the expression, generally you need to make sure that the number of terms that you're having is even number. Like this one, you're having 4 terms, right? So they are even number. Therefore, you can actually factorize it into half. Okay, only half of it. All right. So maybe I will separate it into this part now. The first two term is 1 minus sine theta. Okay, the third and the fourth term will be cos theta minus sine theta cos theta. Okay, so if you look at the action here, the first two terms, there's nothing that you can factorize it out. Okay, so you just copy. And plus, for the third and the fourth term, if you have a look here, you will see that there's a general term which is cos theta and cos theta, right? So I'll make it as cos theta, then minus 1 minus sine theta after you take out the cos. Can you see or not? So I'm just doing a factorization in the second half of the expression. Alright, I only focus on the two terms that I can factorize out the cos. And therefore, when you take out the cos here, you get a 1. When you take out the cos theta here, you get a sine theta. Okay, and then after that, if you look at this whole thing again, maybe what I will do is like, I will put the bracket here. This is 1 minus sine theta. And then you will see that at the end part here also, you're having 1 minus sine theta. Okay, I don't know whether you can see it clearly or not. So maybe now I try to change the 1 minus sine theta as a, maybe as an apple. Easier to draw an apple. Okay, so you're having an apple here. And after that, the 1 minus sine theta here also, you represent it as an apple. Okay, so if you look at this equation now, you're having apple plus cos theta multiplied with apple, right? So if you continue to factorize it, you can take out the apple. So when you take out the apple, what do you have? You're having 1, because apple you take it out already, so here you left 1. And then plus, apple you take it out also, then you're having cos theta. Okay, so eventually, if you look at the steps here, you have 2, then apple multiply with 1 plus cos theta. So what is apple actually? So the apple is actually 1 minus sine theta, right? So you just write in 1 minus sine theta. And you will see that actually we get the answer. Okay, so this is a small technique. Okay, although we might not apply it very frequently, but actually it is worth for you to learn it out. All right. So I hope that you understand how we actually do the factorization for this part. Okay, all right. So this is what we have for example 4. And then usually for a lot of students, they will tell me always that they are very weak in doing all the proving question. Okay, so as what I can say is, what you need to do is I have to practice a lot, because when you practice, you learn from that. You are learning from your experience actually. So you have to practice a lot, and then of course when you are doing the steps, when you're doing all the solution here, you can always refer to the answer, and you can always ask yourself, all right, what can you do to getting closer to the final answer that they want? Okay, so like just now, I know that I need to factorize out the 2. Why? Because from the answer, I know that there's a 2 in front. So therefore, I need to factorize out the 2. So actually, by checking on the final answer, sometimes will give you a hint to guide you, okay, how to continue for the next step. All right. Okay, so this is what we have for example 4. Okay, so maybe you can have a look for example 5. Oh, sorry, example 4 part B. Okay, so these two examples are from past year question, okay? Maybe you can try part B first. For those who want to challenge yourself, you can maybe try. You can pause the video again and then you try it first before you check the answer. Okay, so if I look at this equation here, all right, so in my opinion, the fraction part will be more complicated. All right, so therefore I will start from the left hand side. Okay, all right, so 1 minus tangent square x divided by 1 plus tangent square x. Okay, so if you look at the answer there's no more tangent square, but it only left sine square, which means I need to try to change the tangent become something that related to sine square. All right, so maybe for me I can do it like this, because I know that tangent is equal to sine over cos. Therefore, I can rewrite this become sine square x over cos square x. Then the same thing happen here, it will become 1 plus sine square x divided by cos square x. Okay? Alright, then what is the next step? Alright, so for the next step, for now you will see that you're having a very complicated fraction and you need to try to simplify until there's no fraction. It becomes a term, an expression, which is not a fraction. Alright, and then maybe for the next step, what we can do is like, you're having two terms on top, two terms at the bottom, alright? So I think if we want to make it to simplify in an easier way, then I will suggest you to change, okay, the both terms into a fraction. So that means on top I'm having cos square minus sine square divided by cos square. That means I change the 1 here, become cos square over cos square lah. Then minus sine square over cos square. So this is how you get it. And then for this part also the same, I change it, become the same denominator, and I'm having cos square x plus sine square x divided by cos square x. Okay? Then if you continue, a fraction divided by a fraction, you can change it, become you can multiply it, right? You multiply it with 1, then you upside down, okay? You make the denominator become numerator, and the same thing happen for the numerator. So you're having cos square x plus sine square x. Okay, so maybe your last time, right, if when you have fraction divided by fraction, then maybe you just rely on calculator to get the value. That time maybe you feel very easy lah, but now this one you have to use some basic knowledge, all right, to learn how to actually simplify fraction divided by fraction. Okay, so that's why I said, if can, try not to use calculator in solving or maybe in simplifying some terms, because you learn some technique from there also. Okay, right, so this is what I have here, and that I try to simplify cos square and cos square. Okay, and then for this part, if you look at it, you know that cos square plus sine square is equals to what? It is equals to 1. Okay, so eventually you will see that for this whole part now, you left only cos square x minus sine square x. Okay, then if you try to compare it with the final answer here, we are having 1 minus 2 sine square. So you compare your step with this one. So you realize that here their final answer, there's no cos square. So you have to try to replace cos square by something else. So what can you replace it? So again, since you know that cos square plus sine square is equals to 1, therefore cos square is 1 minus sine square. Okay, so 1 minus sine square. This is cos square, and then minus sine square again. And eventually, you will see that you get 1 minus 2 sine square x, which is the answer that they want you to prove. Okay, so some of the students might tell me that, hey teacher, my steps doesn't look like yours. Can I use the other method? Can. Alright, so for proving part, actually it is quite flexible because they might have more than one correct method to get the answer. Okay, so just make sure that you roughly know okay, how to do this correctly. Well, of course, you need to practice a lot. Okay, alright, so you can have a look for part number C again. Okay, so for part number C, I will start from left hand side again. Why? Because left hand side you have 2 fractions, and then right hand side you have only 1. So that means if you combine them, it will be easier for us to do. Alright, okay, so I start from left hand side. 1 plus sine x divided by cos x plus cos x divided by 1 plus sine x. Okay, so now because I'm having 2 fractions here, and they actually try to combine become 1 in the answer, right? So I will try to combine 2 fractions become 1. So the bottom part, I multiply the denominator with each other. Okay, then to change it, right? So the numerator, what you need to do is that you have to multiply the denominator. Okay, and then the same thing happen here. which is cos square x. So again, if let's say last time when you are in secondary school time, right, you always press a calculator without learning all the techniques, then you might find out that it is hard for you to do all this. All right, how to combine two fractions together? Okay, so you just think that. So maybe you just recall back last time how you do the 7/5 plus 2/3, how you combine them together. So the method is the same actually. Okay, all right. Then after that, you can try to expand it first because you see the thing on top is a very simple value. All right, but my equation here looks very complicated, so I try to simplify it. But before I simplify, I can expand it first. So when I expand this bracket, I'm having 1 plus 2 sine x plus sine square x plus cos square x, then divided by cos x, and then 1 plus sine x. Okay, then if I look in the detail for the steps now, I'm having this, which is 1. Okay, all right, so 1 plus 1, I get a 2. I'm having 2 plus 2 sine x divided by cos x, 1 plus sine x. Okay, and then now I check on my answer again. My answer above got a 2. So my both term here also have a 2. Therefore, I will factorize it up and you will get 1 plus sine x multiplied with 2 divided by cos x, and then 1 plus sine x. And eventually, if you look at it, what do you have here? Cancel off these 2, then you will have the answer that they want you to prove, which is 2 over cos x. Okay, so again, for all the proving part here, generally no one can help you. You have to help yourself, have to actually practice a lot so that you learn from the experience. Okay, so some question, if you are very lucky, the question can be very easy. But sometimes, if let's say you are quite bad luck, you will get a very hard question that you start halfway and then you totally cannot solve one. All right, so again, all this you need to practice a lot. Okay, so nothing much we can help you. I can just tell you that, okay, you can use this identity and so on, right? But you learn more when you try out on your own instead of you just listening to me and then I explain to you how to get an answer. All right, okay, so try to find some example or some question to try out all the proving part. I believe there are a lot. Okay, so this is what I want to cover for this video. And then next video we are going to discuss how to use all this identity to solve the quadratic, or not quadratic, sorry, how to solve the trigo equations. Alright, okay, so I will discuss all this in the next video.